Right, so the first one you'll see is a circuit diagram, and it's got two cells. So remember to connect the cells together, and remember to make sure they are the correct way around. So long line, little line, long line, little line. And you've got an ammeter, a resistor, and a bulb in series with each other. And then remember to connect in parallel. You put the two wires in on top of the wires that are already in there, and connect your switch up. Okay, so that's the first one. And you're going to fill in the gaps. And the other one, wants to work for me, is all you need to do is pull the switch out of the resistor, and put it on top of the bulb instead, and fill in the gaps as well. Remember, when it says closed, switch is closed, that means it's on. And when the switch is open, it's off. So it's like the door is closed and there's a circuit, there's a complete circuit. Okay. So yeah, I want you to set those circuits up. You should have everything that you need in your boxes, and on your desk you've got a switch and a resistor on your desk. So set those two circuits up, fill in the gaps. It should take you 10 minutes at very most. Okay, so with the switch across the resistor, hopefully you saw when the switch is closed, i.e. when it's turned on, the current in the circuit, I know some of you are struggling to see any difference in the current, but the current in the circuit should increase, so it increases, and the lamp gets slightly brighter. Did everybody get that? So this is because the resistance of the switch is very low when it is switched on. It's basically just another wire. And the resistance of the circuit has decreased. So if you think about it, what it's done there is it's given another path for the current to flow along, and a nice easy path. So instead of trudging through a river, it's put a bridge over the river, so it's nice and easy. So the resistance is decreased overall because it's easier for the current to flow this way than it is to flow through the resistor. Okay. And experiment 2 with the switch in parallel with the lamp. So hopefully you saw when the switch is closed, the current in the circuit also, that's okay, coming in, increases. And the lamp goes off. Did you find that the lamp basically just switches off? And again, what's happening there is the current is given a different route to flow. And it's choosing the easiest route. So instead of going through the lamp and lighting the lamp path up, it's bypassed the lamp. It's gone this easy route rather than through the lamp, which is quite high resistance. So the closed switch bypasses the lamp, and this is called a short circuit. So you might have heard the word short circuit before. So it's basically providing an easier route for the current to flow. We don't always want that to happen because sometimes it can overload a circuit. Too much current can flow if you reduce the resistance too much. So a short circuit can be dangerous because it causes the current to rise. This could cause overheating or a fire. Okay.